All right. Yeah, so just to give you a little bit of background, tell you a little bit of a story. So when I first moved here to Australia, I moved here in June of 2016. And is anyone from New South Wales, Sydney-ish area? We had massive rains in June. You know, houses are falling into the ocean on the coastline. It was pretty tragic. So I land on the 16th of June. On the 17th of June, a homeowner types in waterproofing. He obviously has some water leakage, and he goes, can I get your technical manager to come check out my unit? Yeah, sweet. So I walk into the apartment building. It's a penthouse suite, 40 stories in the air, $4.5 million unit. And I walk in there, and it's about as crowded as this is right now. And I'm like, oh, who are you? And oh, I'm the fabricator, and who are you? I'm the builder, and who are you? I'm the lawyer and the insurance guy. And this is what I saw when I walked in there. $4.5 million penthouse suite, right in the heart of Sydney CBD. So they go, you're a tech guy, you know, what's going wrong? And I'm, well, you know, I've been in Australia 24 hours. I'm a bit jet lagged at the moment. I'm like, what kind of construction is it? He goes, oh, it's D&C. I'm from the States. What's D&C stand for? And the insurance guy, without missing a beat, goes, duck and cover. So, you know, this is kind of the state that we're in at the moment. We have lots of windows like these. I see this kind of stuff all the time, every day. And there's a variety of reasons for that, and that's what we're going to talk about over the next 40 minutes or so. So we're going to talk about some of the shortcomings. This is kind of preaching to the choir, I know, but we're going to talk about some of the shortcomings. We're going to talk about why those shortcomings are causing systematic failure, like we just saw. We're going to get a better appreciation for the complexity of sealants, because I was amazed that everyone just says Sika it, and there's no, well, is it silicone, is it urethane, you know, all the complexities there are there. And then we're going to talk about some innovative and newer ways to do some of this remedial work, because we do have a plethora of poorly fabricated, poorly installed window assemblies. A lot of imports of windows that really don't meet the Australian standards. First, to get a general understanding, most of Australia is dry glaze, so we use rubber gaskets to keep the water out. Other than Victoria, they just have to be different to be different. So they're mostly wet glaze systems using silicone sealants primarily. We have a really big problem here. We have glass that falls out of buildings all the time. You know, it was kind of interesting when I came over and I was like, really? Like glass falls out of buildings? And they go, yeah. I was like, oh, you mean like one piece? They're like, no, like one every couple of months. And there's some of the more common ones that are in the news currently. This one blows my mind. 215 panes of glass and counting still. And what happens when glass falls out of the building? It makes the news. If you type in glass falling out of buildings Australia, this is just the first page of Google, and these are all different projects. You know, it's catastrophic. It's borderline, you know, a plague in our industry at the moment. The only reason why this hasn't become more of an impact is because we haven't killed anybody yet. So when you see stuff like that, this is actually on a building I was standing on. It's the same one that was leaking water. We're on the balcony, 18 stories up. Someone says, I have water coming in my balcony, or coming in from the balcony into the apartment. So we're standing out there and we're looking at the waterproofing, and okay, we know what's wrong with the waterproofing. And I look at the glass, and as I'm standing there, you can just watch it tip over, drops 18 stories, lands on a covered walkway. This is in the heart of the CBD. That pane of glass is 1 meter by 1 meter, 9.5 mils thick. Hits with 140,000 newtons of force, 4,000 breaks your femur, which is the strongest bone in your body. So it's like dropping 2 African elephants on you. It is going to cause massive, massive damage. So I started thinking about it. I'm like, you know, we do kind of have this epidemic, this plague at the moment of bad imported glazed units that are probably not being installed as well as they should. And what's going to happen? What's the end game? What's the financial burden that this is going to cause? And then I started thinking about the cladding industry and the problems that we're facing there. So you see articles like this. Builders are having to replace cladding. And I think the glazing industry is going to follow the same suit. You know, you have these cladding problems, these non-compliant, non-conforming building products that were being used. builders are having to foot the bill, and these are millions and millions and millions of dollars, 20, 30, 40 million dollars a piece. They're now pushing that back on everybody else. One of these is actually, they're going after the certifier and the fabricator and the manufacturer and everybody involved, because they're saying, well, we're all industry experts. We all should know a lot better than what occurred here. The government's not going to dump it onto these apartment owners. They're going to push it back on the industry professionals that should know better. And they're going to take their cue from elsewhere in the world, just like we've done with cladding. We haven't had that big, dangerous fire that's killed a bunch of people here. That happened in Europe, and the Australian government said, well, we have the potential for it, so we're going to react and take proactive measures. Same thing's going to happen with glass. The moment we kill somebody, the government will step in, I can guarantee you it, and they're going to sit there and they're going to put this financial burden back on us. And here's the reason why. So this is just a risk analysis chart. It happens, so it's just the probability or likelihood that an event's going to occur, and if that event occurs, how costly or how dangerous is it? So with things like fire, a big fire rarely happens, but when it does, usually you lose the entire building. And that's why there's this big push to get combustible cladding off of buildings. When glass starts falling out of buildings, when you have unitized curtain wall systems where panes are falling out 30 stories in the air, where you might have to completely reglaze a 30-story curtain wall, that's just as catastrophic, but it's much more likely to occur just because of the construction methods we're currently using. So let's talk about some of the shortcomings. Well, some of them is the materials that we're using in Australia. So we have birds, lots of them. I know Sydney does. My car's always covered in droppings. Birds tend to pick out rubber gaskets. They like to use them for nesting. So I've actually talked to a ton of strata managers, a ton of property managers, and I go, hey, that pane of glass that fell out on the 18th story, that's a dry glaze system. Where's the rubber gaskets? And he's like, oh, the birds come and pick them out. Don't worry, though. I went to China. I got a roll of 4,000 lineal meters, and I just cut it and replace it every summer inspection. Yeah, right. What do you do about the rubber gaskets on the outside of the windows? And he's like, oh, there's rubber on the outside. I'm like, yeah, both sides. You're not reaching over the balustrade. You're not getting on the outside of a unitized curtain wall to replace rubber gaskets there. So we need to think about some of the materials you're using because of the wildlife that we have. The other thing is the quality and the knowledge of the fabrication process. So if we're going to do a dry glaze system, those rubber gaskets should be 2 different stiffnesses. And there's a reason for that. The internal one should be a lot stiffer, a lot harder, so that it doesn't compress as much when the wind hits it. If the wind hits that pane of glass like a sail and over compresses that internal gasket, the outside one loses compression and will fall out. And then the other reaction happens. So we need to think about that. I mean, how many windows do you see that are using 2 different stiffnesses of rubber gaskets? Usually it's just one, and I do the inside of the window, do the outside, move on. The compound, what that rubber gasket is made of, makes a huge difference. There's a variety of chemistries. EPDM and neoprene are probably 2 more common ones I see here. But they make silicone-compatible rubbers and silicone gaskets. And based on our climate, they might be better materials to use just to handle our extreme weather conditions, our extreme heat, our extreme solar loading. We get a lot of this. I see this all the time. It's pretty common. It's a brutal climate from the sun's standpoint. And actually, if you look, a study was done by the government, and rubber gaskets in this climate tend to last about 5 years. So imagine if you're a big design firm or a big builder or a big asset owner, and you build this beautiful 40-story building, punched windows or big curtain wall system. I mean, did you tell the client that in 5 years they're going to have to completely reglaze their building? Probably not. So we need to think about some of the materials we're using for our climate. If we're doing silicone sealant for Victoria, maybe other parts, we need to think about chemistry. We need to think about, do our setting blocks, do our shims, do our packers, do our spacers, do they chemically react with our silicone sealants? Do they cause degradation of the bond line if it's structurally glazed? Because again, that results in glass falling out. Are we doing the testing, or are we just substituting for the cheapest product we can possibly find? This is actually a car dealership in Brisbane where I bought my car when I first moved here. I'm sitting in their office and I look over and I see this butt glaze of the joint and I was like, wow, that's a pretty neat effect in the glazing laminate. And then I look closer and I can see the glass actually starting to split at the laminate level. And this is staining. And I asked the guy, I was like, how old is this building? And he's like, oh, it's brand new, 3 months old. I was like, wow. I was like, all this glass in the whole building has this effect to it. I was like, are you guys getting it replaced? He's like, oh yeah, we're getting the fabricator to come back, the installer to come back, and it's going to cost them about $200,000 for something that, a couple of bucks. So there's the parts and pieces, then there's how those go together in assemblies. So how many people see this if you look on window assemblies, especially imported products that come from overseas? I see this all the time. And that is a dead giveaway of a poorly fabricated window in a dry glaze system. So what that is the rubber gaskets being turned up so that you can do the installation, the fabrication a lot faster. The problem with that is it's not sitting down in the frame. So if you get on your knees, you can actually look into the building. You can see daylight. So water's getting in there, air's leaking out, energy costs are really high, and it's just a poorly fabricated window. That should be a 90-degree corner. That should either be two pieces cut together and butted in with silicone sealant, or just two pieces, a molded corner piece. But certainly not that. It does not work. Again, picking the durometer of the gasket, this is a museum in South Australia. I was presenting on glazing in this museum, and that's a foot away from my face. And I go, oh, you want to see an example of bad glazing? Here you go, right here. Again, the rubber gasket couldn't handle the wind loads, and it starts falling out of the building. And then there's the installation. As we pick our sealants that we're going to wet seal with, as we're going to put weather beads on, subsil flashing details, that sort of thing. There's different products and different chemistries, and we need to assess, and it's not always going to be silicones the right answer. Sometimes hybrids of polyurethanes are the right answer. Sometimes silicones absolutely are the right answer. And we need to think about the trade-offs of those different chemistries. Most manufacturers will have a big chart like this that says, what the substrate is and movement capabilities and all that fun stuff. And that usually helps you, but you need to take it another level. Think about whether or not you're painting your building. So are you doing a punched open rendered building? Rendered facade that is going to probably get painted in 5 or 10 years. I probably don't want to use silicones there because the likelihood that the building's going to get painted, they might want to paint the sealant to change the color, instead of having to cut out the sealant and recaulk it with something else. If it's a curtain wall or a steel structure, silicone's the way to go because I don't have to worry about painting. No one's ever going to paint a window. I need to think about movement capabilities and the engineering. I mean, the number of times that I see joints in window assemblies that are 5 mils wide, and you talk to the engineers, well, what's your expected movement? I don't know. Wow, okay. How's the fabricator, how are the installers supposed to do their job properly without getting the right information? How do they select the right materials without the right information? Got to think about differential movement, got to think about materials expanding, contracting. This window was 40 stories in the air. That sealant bead just debonded the first time it went through a thermal cycle. So 3 months after the building was constructed, they lost the bond line. Water had been leaking into it ever since. Because it's 30 stories in the air, it's not easy to get to the outside to cut it out and fix it and recaulk it. So what turned out to be saving about $1.50 a sausage is now going to cost the builder about $22 million to fix because of water damage. Mold in the building, floorboards being completely destroyed, entire units not livable anymore. And then there's the one that I see all the time, and I actually love bringing this up with architects. So how many people see this detail? Just your standard sill detail, right? They just, theory is, water runs down, hits the subsill flashing, gets out of the building. The designer never thinks about the fact that our subsill flashing isn't just one long continuous piece. We have butt joints. If they're not installed properly, if they're not detailed properly, this system fails. Water hits the face, goes into the subsill flashing, hits that gap between the subsill flashing pieces, gets behind the cladding, soaks the wall, causes degradation, causes mold, causes mildew. In this case, and this is actually a government building down in Canberra, they switched from lightweight cladding or lightweight structure to cast in place. So the concrete guy does what concrete guys do, and he made the window rough opening smaller than it should have been. The windows were already fabricated, so they actually didn't have enough room to shim it, to slope it out. So it's actually sloped back into the building. So water doesn't end up here, which is bad. It ends up in here. So what's the rectification? Well, in this case, they're actually looking at ripping out every single window in this building just to replace the subsill flashing. It's going to be an incredibly costly exercise. The easy way to fix that before the construction is you get your butt joint between your two subsill panels, put a bead of sealant there. You can't put sealant over it. You can't put sealant in it. There's not enough depth to create a proper sealant joint. So instead, do a face seal of a silicone bandage, something that's going to take that movement and flex as the metal expands and creates a proper seal, a proper flashing. So I wanted to talk about some case studies. I was hoping to use some of the ones that we have here in Australia. Unfortunately, a lot of them are still trying to figure out who's going to be on the hook financially for them. But I do have some from the US and elsewhere in the world. So this is a project in California. Metal joinery, all too common. You know, if there's a void, put some goop in it. We'll worry about it later. Obviously failed something chronic. Looks terrible, doesn't perform. And instead, again, you could face seal with a silicone bandage. It's going to be durable. It's going to last 20 plus years. So here's a little video just to break up the voice. This is a Point of France. It's an apartment building. And again, what was really neat about this type of technology and the way that they did the rectification is they didn't have to evacuate tenants out of the building. There was minimal disruption to the tenants.
Hi, John Bauer here with Tremco Commercial Sealants and Waterproofing on the site of the Point of France in Edina, Minnesota. Some of the challenges we encountered in here were substrate. The substrate is a very rough stucco finish coated with an elastomeric paint.
Because the jam joints were a little small or they didn't have enough metal for your 1/4 inch adhesion. And then at the head section and even the head so horizontal, there's like 3 joints that we're covering up.
Some of the joints were really, really wide. The person who went through and did some replacement caulking on it made the joints that only needed to be about 1/4 to 1/2 inch, made them about 4 inches. So the Simple Seal was nice to go over all joints.
I guess I just like silicones, period. And I know that the Simple Seal act just as well or better than regular liquid silicone, so I like the 20-year.
I mean, since it's a redo, trying to get it down to a good material where you know you've got a good bond. This has elastomeric paint on it, so you got that challenge. You've got multiple different kinds of caulking. You got that challenge, and I do believe the head of the window system had a total of like 3 joints. So that's a lot of time to clean up. And this part, all we had to do was we V'd out a channel, put fresh caulking in there, so we got a good bead, and then we adhered the Simple Seal to the substrates.
I've been fortunate in this market that I've promoted Simple Seal as a solution on multiple projects, and it's well received. As a result of that, I find more and more consultants and contractors bringing forward Simple Seal as a solution to solve a myriad of potential issues where recaulking does not make sense.
I started out with the curtain wall for splice joints and actually installation for flashings. And I've found it very useful now on renovation or recaulking when there's bad sealant joints, because the joints are just too small to function properly, so we went right over top of them.
Certain applications of roof to building, we've done a lot of that, but skylights are a troublesome area, and I've done a lot of those, big ones, and it seems to help a lot. If I think it's going to help the project and it's going to work a lot better, I'll use it all the time. I'll bring it up anytime.
I think there's a lot of really good content in there from a technical standpoint that I think is really good to know. And there's some photos of the project, so Building owners and tenants, the biggest thing they care about is water not getting into their building, the glass staying in place, their energy bill dropping because it's properly sealed, and aesthetically it still looks just fine. Here's another building. It was a storefront system, and we molded an overlay system to go right over top of the original gasket system. So you have a storefront corner detail, we have this overlay system, and literally just glue it in place. So speed of install is really prominent there. You're not disrupting the tenant inside. I'm not taking out any of the window systems. And it's just a nice clean line. It's weather sealed. And again, I've just added another 20 years of useful life out of that system. Here's another one where it's a gasket system. We came up with, they were doing a massive building renovation. It was a government building. And what was really interesting with this building project is the client, the federal government for the US, yeah, they go, we're doing all this renovation, we're patching up some render areas that were pretty poor, we're repainting the building, we want to weather seal the windows while we're there, and that way we have another 20 years of useful life out of the building. We reduce our energy consumption, we reduce the operational costs, so there was a financial incentive for them to do it. And since the swing stages were already there, they said, let's do it in a single crack. So there's one of the existing windows, 20, 25 years old. It's seen the end of its useful life. The option, based on its construction, typically would be rip the glass out, replace all the rubber gasket in it. It'd be very disruptive to the operations of the building inside. So instead, they took a molded silicone bandage that we did, notched it out, solvent wipe it, physically install it in place. Pretty simple, fast. And then just shoot a bead of black silicone sealant and tool it off. And that's what it finished up looking like. And that's going to last another 25 or 30 years. Really good building, extending the life of a very expensive asset for the client and giving them a more effective building than what they originally had. Then there's skylights, whether it's Perspex or polycarbonate. Maybe you have pressure bar systems. Again, all these fastener holes were leaking. The gaskets were fatigued and leaking water in. Most of these are on big atrium areas, so usually they're stone or they're tiles on the floor. So as those things are leaking, a lot of people slip and fall. Really common in Victoria, really common in New South Wales. And a lot of these atriums, since day one, they've leaked. So again, we're looking at a couple hospital projects that we've done one, and we're looking at a few more where they've said, yep, it's been leaking for 20 years. We've pumped as much goop as humanly possible. We have no clue how to fix it. So this is the way we're going to fix it. We're actually going to, all this joinery, all these connection pieces, everywhere that it's leaking, we're just saying, you know what, enough's enough. We're going to go right over the top, and we're going to seal glass to glass, because I know glass doesn't leak, and then if I seal everything else up, that won't leak either. So again, just silicone sealant and these molded overlay systems. So I think it actually looks better, it functions a lot better. It's just a cleaner system overall. There's this one, and this is your curtain wall system, all this metal-to-metal joinery that we have. How do we seal those from leaking in? Even the most well-built window still leaks at all these joints. So we created a crucible, a silicone crucible. All you do is you pump a bunch of goop on there, stick it in place, tool it off. That same part, if you want to go at the sill detail, just knock off 2 legs of it, and there you go. If you're doing a corner detail, knock off 3 legs, and again, happy days. And that's what it looks like. But it functions really well. So aesthetically, most people aren't going to see it other than professionals, but functionally, it functions a lot better. So here's another video on Puerto Rico.
The Puerto Rico Convention Center is easily the largest and most technologically advanced convention center in the Caribbean. Newly opened in 2005, the structure's unique design consists of 2 skylights. The upper portion, with its wave design, covers the exterior portions of the building. Over time, the skylight system has been put to the test in this tropical climate. The combination of movement and elements impacted the glazing seal at various points along the framework and hurricane clips of the system, causing many leaks throughout conditioned areas and the terrace sections. These stain marks belie additional damage from frequent leaking. Design engineers from the Tremco CS&W Glazing Solutions Group created a glazing restoration system comprised of Tremco Simple Seal extrusion, a custom silicone overlay extrusion, and Spectrum 1 silicone sealant. As you can see from this rainstorm footage, the structure is dry and weather-tight from a successful restoration effort. In addition to mitigating damage during restoration and extended interruption to the convention center's activities, the solution provided considerable labor savings as the efficiencies of this install allowed the applicator to complete over 800 lineal feet of the gasket overlay system per day. The entire project was wrapped up in 94 continuous workdays by national building contractors.
Right, it's this massive convention center in the Caribbean. It was leaking like a sieve. We went down there, helped them come up with a pretty unique solution that saved them a lot of time, a lot of money. The timing of it, though, was perfect because about 30 days later is when Hurricane Irene came through the Caribbean and pretty much leveled all of the Caribbean islands, including Puerto Rico. And they actually used that as a shelter for a lot of the people. So it was really good, great testimony to sit there and say, well, it survived a Category 5 hurricane 30 days after it was installed and didn't leak. But it was nice that that structure went the way it did. And that type of technology, whether it's us or anybody else, I know there's a lot of Tremco marketing, but that's because the marketing guys, you got to say Tremco 1,000 times to keep your job. It can be used for all kinds of applications. Maybe you have a historic building. There's a lot of historic buildings. So this was the one in New York. If you've ever done any projects in New York, they're incredibly stringent with historic buildings. This was 100 years old, 120 years old, I think. And the historic restoration architect said, I want it to look exactly like this single pane putty glaze that was done in the 1880s. I'm like, that's awesome. And he's like, but we want to make it super high performance, revolutionary, drop our energy bill, So I want performance, but I also want it to look really old. Fantastic. The other problem they had is they were creating a lot of condensation. And this is a library with a lot of rare books. So from a building maintenance standpoint, they had to improve this system. Some of these books were worth hundreds of thousands of dollars, if not completely irreplaceable. They couldn't have condensation and mold starting to develop. So they actually said, while we're doing this, we're going to turn this into a double glazed unit. So again, add performance, but still make it look like a turn of the century, 100-year-old single pane putty glazed window. So it was a nice challenge. So what we ended up coming up with was structural silicone and a rubber extrusion that looked exactly like the original putty glaze. So we took out the frames, sandblasted them, repainted them, installed the glazing tape, dropped in the windows, structurally silicone sealed it, and then put this overlay system so it looked a lot like the original putty glaze system. The heritage architect for this was probably one of the pickiest people I've ever met in my life, and he gave his stamp of approval for this. So it was really good. It's a really good testimonial for this kind of technology. And those sort of things, whether it's us or anybody else, they come in a variety of colors and shapes, and there's definitely a place to be using these in our market space. And there's other types of technology. So, let's not think about just, well, we'll cut out and recock it, or we'll use the same rubber gaskets we did for 20 years, and they're leaking like a sieve, and glass is falling out of buildings. I mean, the storm is coming. The government is going to drop the hammer on some of us. So think about other technologies. Pre-compressed foam tapes are a great one because they take off a regular substrate. So rendered walls and textured facilities and stuff like that. You can use them as a primary seal. They're really quick. Trying to tool that with a sealant, it's going to look terrible. You're probably not going to get great adhesion, so it's going to fail prematurely. It's going to allow water into the building. And then you're going to get called back. You're probably going to get sued, and none of us want to do that. And there's all kinds of applications for that kind of stuff, handling irregular substrates that you couldn't bond to, sandstone being a really good one. You can't use sealant for sandstone. It doesn't adhere to it. So using something that relies on compression, not adhesion, is a really good technology play. And you can even paint it if you want to hide it. So I know I covered a lot of stuff, and I could talk all day about this stuff and what we need to do better in the industry. This video in particular is very heavily marketed, and for that I apologize, but it hopefully gets a lot of good content and a good message of, as we're fabricating, make sure that we do our homework and pick the right products and the right pieces to build great windows. As we're installing them, let's do the homework and let's work with each other to make sure that we're doing it properly.
It's one of the unique things about Tremco. I like to say that Tremco knows glazing. We compete with some competitors on the engineered rubber products, the gaskets, the setting blocks, the spacers and things like that. We do it all.
It's going to give the owner the satisfaction of having one supplier. It helps with warranties, it helps with issues. If we have leaks or issues on the job, we know where to go.
Tremco has best-in-class design engineering capabilities, both on the design side and in the structural glazing and silicone side.
When we're looking at, for example, sealants to be used, we want to make sure that the sealants adhere to the various metal finishes and the other components.
And you may ask, well, why do we need to do some of these tests? Well, many times, even before a job start up with your contractor, the contractor may be needing a certain sealant and they have certain types of substrates. It's not always concrete that you're trying to put these products onto. So they may want to know, well, how well do these things stick?
So we have adhesion and compatibility. And then when we look at the weather sealing aspect of the building envelope, where we go from the glazing to maybe brick or stone, we want to be sure that the sealants do not cause any staining.
Well, the pull tests make sure that you actually have a recorded value and that you're getting a cohesive failure instead of adhesive failure.
But likewise, we have a technical service team that oversees not only that lab testing I talked about earlier, but construction document review.
And there's a lot of mathematical calculations that need to be made to make sure that the sealant, you're actually using the sealant to help hold the glass.
Typically, we will get metal drawings with glass included from our customers, and we will take those drawings and fill in the blanks. So they give us a little bit of a blank slate and allow us a little bit of creativity on how we can solve their problems.
And then we move into the services related to proper gasket design. And we have a whole crew that focuses just on that as well, our design engineering group.
Specific to restoration, one of the tools that we have in our facility is a 3D printer. This helps reduce the turnaround time for our customers. We're able to print something out, usually within a day or two, get that out to our customer. They are able to look at it quickly in the field and make the determination if they want that part or not. We'll design it, they'll okay it based off of some dimensions. We then send that over to our quoting department to get a quote rolling to get the project rolling.
Our test wall, I think, is a critical piece of the solutions-based offerings that we provide. One of the things when we make our recommendations, the test wall enables us to make sure those aren't just theoretical, but they've actually been tested in our lab.
It's really a benefit for not only the client, but the project itself. I mean, keeping it under schedule and making sure that it goes smooth. Being able to see issues on a mock-up like that before they go out to the field, it's big.
If somebody tells you something, that's great, but if you have someone else cross-verifying all of those quality assurance things, it's a really a good value add in terms of knowing that when you put Tremco on your building, there's a good level of service that goes with that.
And with our team of 70 field representatives, it's very easy to contact them and have them come out and take a look at the details and ask a lot of questions. We do have to address the performance of the weather seals and the coatings if we're going to keep the buildings operational and provide indoor occupant comfort.
Just wanted to wrap up real quick because I heard the applause over there, is we need to build better systems. We need to repair all the bad systems that have been imported and installed. I'll tell you a really good story, an inspirational one at that, is I was meeting with a tier 1 builder about a week ago and meeting with the mid-level procurement guy, and he's like, Steve, we want to buy all your gaskets and all that fun stuff off of you, and we're going to buy our glass from Veridian, our framing from Capital, and then we're going to take it all and we're going to ship it over to Asia, and we're going to have them assemble it, and then we'll bring it back. He's like, what do you think of that idea? I'm like, I think that's a terrible idea. He's like, really? I'm like, yeah, I've seen a lot of the stuff that comes out from over there. There's not quality in the fabrication. And his boss is sitting there and he's like, well, what do you think is going to happen in the industry? And this is a major tier 1 builder. I go, if you decide to go down that road, I guarantee you won't be here in 10 years. I can guarantee you, as a tier 1, 2, 3 in the market builder, you will be bankrupt. The government's going to hit you with hundreds of millions of dollars worth of defects. And he goes, yep, you're absolutely right. So they're actually switching over and they're going to start buying nothing but Australian-made window assemblies moving forward, which I thought was fantastic because they got about 200 buildings being built currently. So that's a really good thing for the industry. But we do need to keep moving it forward and we need to do it together. So I appreciate it. Thanks for paying attention. If you have any questions or want to talk, let me know. Thanks. Thank you.